Cool. So we are live. I'm just going to pop a tweet out to get some friends from the Twitter sphere with us in here. Give us 2 seconds and we'll drop the tweet in the chat as well. If you could help us sort of get the message out, that would be great. But welcome everybody for the latest Developer DAO workshop. Super happy to have Abby and Ed here from, I'm never quite sure what to say, guys. Are you from Hedera or from Swirled Labs? Or how does it, like, how do those intros supposed to work? Because I know they're related, but they're not exactly the same.
Yeah, so I'm a developer evangelist for Hedera at Swirled Labs Incorporated.
Yep. Nice. And that's like an entity in the ecosystem, right? Like serves the foundation. Yep. Okay, cool. Awesome. Yeah, so delighted to have Abby and Ed here with us today. They're going to be running us through an interactive workshop on building scalable Web3 applications on Hedera. Abby can go into that more in a minute, but there'll be a nice sort of walkthrough of detail and then an interactive session at the end, a coding session. So check the prerequisites in the comments and the descriptions below if you haven't already. But Abby, Ed, do you want to go first? Abby, would you like to sort of introduce yourself, say a little bit more about kind of who you are and what you do at Swirled Labs?
Yeah, so my name is Abby. I'm a developer evangelist. I joined about 5 months ago, so I've been learning a lot. I've been meeting great people in the community, and I've been helping create tutorials, workshops, write some articles, and just been having a great time. Thank you.
Nice. Welcome. Nice to meet you. And Ed?
Yeah, Ed Marcus here, also a developer evangelist for Hedera at Swirled Labs. I've been part of the ecosystem maybe a little over a year now, and very much like Abby, contributing in the form of tutorials, maybe documentation, some support for the community members to help them build. And it's definitely a very good time, very exciting times to be part of Web3. So happy to be here, guys.
Yeah, for sure. I feel like it's time for the builders now, right? Like there's all of the capitulations happening, and like hopefully we're left with mostly the people that want to build stuff.
Exactly.
Awesome. So I'm curious, as I was looking into it, I don't know a huge amount about the Hedera ecosystem, but could you like just explain, I don't know if you were going to go into this, Abby, but just real quick, kind of how Swirled Labs like relates to Hedera and kind of how that relationship works.
Go ahead and take this one, Ed.
Oh, sure. Happy to. So in the beginning, it was just Hedera, right? But with the purpose of decentralizing the operations, the network itself, then different organizations were stood up, right? We started with the foundation about a year ago. And the foundation is the ecosystem development fund that gives grants and supports builders who want to come to Hedera. So that has been around for about a year. It's one of the largest, if not the largest, ecosystem fund in Web3. And then maybe earlier this year, I think it was in March or March timeframe, April, then Swirled Labs came, and that is where a lot of the engineering work and contributions and a lot of the marketing work for Hedera is happening. And so now Hedera is just the council members, so big organizations or businesses and universities that are doing the governance for the network, running the nodes, and doing all those interesting things with very few folks involved, just the necessary folks to do legal work and finance work, and that's it.
Okay, awesome. So it's like a node in the ecosystem that kind of like serves, maybe granted from the foundation, and like serves to help grow the whole ecosystem.
That's right.
Sweet. Okay, cool. Yeah, it's super interesting. I think a lot of DAOs are going down that model, or a lot of protocols are going down that model in terms of like granting out from a foundation. So it's interesting to see how Hedera and Swirled Labs have gone on that journey as well. So Abby, do you want to give us a little kind of quick summary of what we'll be going through today? See if anyone's got any questions.
Yeah, definitely. So I'm going to be giving sort of like a PowerPoint presentation about an introduction to Hedera, what Hedera offers, what services it offers, and then I'll go into a interactive coding portion, which will go over creating a fungible token and then importing the account that we create that into Hashgraph wallet so we can see what we've created. And then along the way, if you have any questions, feel free to leave them in the comments.
Nice. Cool. Awesome. And the housekeeping that we had for folks is mainly at the end, right? There's some prerequisites around signing up to some bits that we dropped in the comments that it would be good for people to do kind of whilst you're talking, or do you think we get to that when we set up the exercise at the end?
Yeah, if you could do it while I'm talking, if you haven't done it, just going over to portal.hedera.com to sign up for a testnet account. And then also signing up for CODESANDBOX, as that's what's going to be used for the interactive section. And in order to fork the sandbox, you need to have an account.
Nice. Cool. Awesome. So shall we get to it? Do you want to kind of kick off the presentation? Ed, should we maybe leave the screen to Abby so she's got a bit more real estate?
Absolutely. Let's do that. And if I think, as Abby mentioned, if there are any questions that come up, she'll be happy to take them, and I'll be behind the scenes also supporting along the way.
Awesome. Sweet, man. Cool. Go ahead, Abby.
All right. Let me go ahead and share my screen. You can see that just fine.
Oh, I'm clicking the wrong buttons. Yeah, it's coming through for me, mate. You look good.
Okay, awesome. Well, thank you. I want to thank everyone for being here, taking the time to watch this live, and let's get started. So I've already introduced myself, but I'm going to go ahead and do that again. My name is Abby Castro. I'm a developer evangelist for Hedera at Swirlds Labs. And a fun fact about me is that I have 4 dogs, and here is a picture of all of them. They make me really happy. They also can make me really stressed, but when we all work together, we have a happy house. This is Charlie with his tennis ball, Nori in the upper right, just basking in the sun. And then I have Luna, the Siberian Husky, and then Snuffles in his Christmas outfit. Another thing about me is that I value maintaining the integrity of natural systems, and I'm very proud to be a developer evangelist for the greenest, most used, and sustainable public ledger for the decentralized economy. So previously, I was a full-stack software engineer, and I enjoy the opportunity to be able to connect with other engineers, talk about anything really. So feel free to reach out to me on Twitter or on LinkedIn, and I'll get back and just have a natural conversation. So today's workshop is build scalable Web3 applications on Hedera. But before I jump straight into it, I'm just going to give you a brief sort of introduction of what this talk will be about. So first I'll give an overview of Hedera, and then jump into understanding some of the Hedera network services. And then we'll dive into a technical workshop. And at the end, I will show a slide where you can see other resources in order to learn more and get more involved with the community. So before I get started, I'd like to take a step back and sort of take a look at the internet in a larger scale, like a bird's eye view. So pre-1970s, we had the analog era. And this was a time where a lot of information was just tracked on paper, and it wasn't very efficient. As technology likes to evolve, we entered the digital era in the 1970s, where we gained speed and we had mainframes and computers. As that continued forward, we entered the internet era in 2000, and on top of speed, we gained access and collaboration. This is where we had open access to information, and other people around the world were able to collaborate. It was a very exciting time. This is what's known as Web 1.0, and it was a time where the internet was great for value exchange. Most of the people who were contributing to the internet were ones who had the opportunities to learn how to work with computers and to put information out there, and a lot of these sites were mainly static. As we continue forward, we were able to enter an internet era that was more social and mobile, and you no longer really had to be a main developer to contribute. There were people putting blogs out, people messing with MySpace. There was just a lot of ability to be able to interact with the computer and even collaborate more. But along with that, we also started getting some valid concerns about our privacy, about data ownership, and in terms of large creators, like where was our data going, what was happening. And so from there was born the trust era in 2009. And this is where the foundation of Web3 is being built today. There is value exchange and decentralization at the core thanks to these decentralized networks. And it's also very important because as we continue forward, it's just going to evolve more. So it's great that everyone is here to sort of learn together and see how everything's going. So at the core of this evolution are distributed ledgers, which is what I want to talk about next. So what are DLTs? They're peer-to-peer networks where multiple members maintain their own identical copy of the shared ledger. In this visual here, it shows that the entire network verifies, executes, and records each transaction without relying on an intermediary. In contrast, we have the centralized ledger, which does require the central authority in order to communicate everything to participants. And the major key difference, as you could see, is that the traditional ledger has that central authority and the distributed ledger is independent of it. Transactions are automatically mirrored across all of the nodes, which makes sharing information very, very quickly. So now that we know that main difference, let's jump into some of the qualities. Well, for DLTs, there's no central point of failure to attack. They rely on cryptography, and a participant doesn't need to trust any other participant to guarantee that the ledger is valid. In fact, most DLTs will have 3 of the same building blocks. There's the ledger itself, a consensus algorithm, and an incentive or rewards for the network of participants. And a lot of these are in the form of cryptocurrency. And so what does this have to do with Hedera? Well, Hedera is a 3rd generation public distributed ledger that provides 10,000 transactions per second at a fraction of a cost with a final consensus confirmation in 3 to 5 seconds. It's a long way from the 1st and 2nd generation networks, but I think it's important that we also compare Hedera to other 3rd generation DLTs, and that's what the next slide covers. So here you can see some of the differentiators are in the transactions per second, in the fixed transaction fees, but the one that blows my mind is the energy efficiency. So the UCL Center of Blockchain Technologies created a report of various different networks, and all of the data points that as more transactions occur on the Hedera network, the less energy consumption is required, which is amazing for my personal environmental goals or anybody out there to know that they're building on a network that is not negatively impacting the environment. So what makes this possible is the algorithm that powers the Hedera network. This algorithm is called the Hashgraph, and beneath its surface is a different structure that solves the same problems as the traditional blockchains. But let's bring our attention to the traditional blockchains first. What we know is that proof of work will typically require some heavy electrical computational requirements. There is no guaranteed consensus, and to some degree inefficient due to having to prune stale blocks, on top of being slow, but for security reasons. On the other hand, Hashgraph is an open source consensus algorithm and data structure that allows a network to have a carbon negative infrastructure. It uses a directed acyclic graph, also known as a DAG, and internally uses gossip about gossip and virtual voting. This is the heart of the new technology that enables the high throughput and allows us to be the most sustainable and reduces costs drastically compared to the 1st and 2nd generation networks that we saw previously. So instead of having to prune the growth, you weave everything back into the body of the ledger. So next we'll take an overview of the network. So at the heart, we have the Hashgraph consensus, which we briefly talked about. And then we have the network services, which is a consensus service, the token service, and an EVM-compatible smart contract service. The next thing I want to talk about is the governing council, which is very important. It's a group of organizations, and they come together and they help make decisions for the network. It's made up of large companies and top universities around the world, and it brings decentralization, transparency, and trust to the governance of the network. On top of this foundation is where applications are built for process integrity, identity, tokenization, and payments. But let's dive a little deeper into the Hedera Governing Council. We have up to 39 organizations from a variety of industries, continents, and countries. They've come together to make future decisions about the network and the product roadmap. And I'd like to highlight that each member is required to run one node. But they're also diversified through time, which means that they can only serve a 3-year maximum term with up to 2 consecutive terms. Once their term is up, it is the responsibility of the organization that is departing to find another organization to fill that seat. So that ensures that there isn't an empty seat lying around. Each member also has an equal influence of 1 vote. I also wanted to mention that there are different levels of decentralization within DLTs. And in one dimension, they can be permissioned or permissionless. And in the other one, they could be public or private. And that's how we end up with this quadrant. So with public and permissionless, these are the highly decentralized, and in today's landscape are the networks like Bitcoin and Ethereum. The public part will mean that anyone can build applications in the network, and permissionless means that anyone can run a network node. There are public and permissioned, and that's where Hedera falls. Anyone can build applications on the network, but the nodes that constitute the network have to be invited to join. And then private and permissioned, it's the one that offers the least decentralization because both the application and the network nodes have to be invited to join and provide some form of identification. Currently, Hedera is public permissioned, where anyone can deploy. However, we are on a path to becoming permissionless. Let me go ahead and go there. I want to talk about that path, but before I do that, I think I skipped private permissioned. So the private part of that is that applications have to be known, but the permissionless is that anybody can join. So let me go through some of our decentralization paths. So the phase 1 is the governing council. Here you can see that they're all over the place except Antarctica. They're in every continent. And we briefly talked about this as well. Phase 2 is permission nodes, or also known as community nodes. And this is an opportunity for everyone knows who you are, but you're able to contribute to consensus. A couple of months ago, we also introduced staking, which is exciting because it now enables another mechanism for the community to contribute to consensus, which will open up even more once community nodes come along. Phase 3 is permissionless nodes or anonymous nodes, and this is where anyone can run a node and contribute to consensus, and it represents the network in the most decentralized state. As the network continues to grow in use cases, with over 14,000 developers attending global hackathons, meetups, and being active in Discord, there have been over 1 million total accounts on mainnet, and there have been a good variety of use cases that are coming from individuals and smaller teams as well. I'd like to dive into some of these network services that developers use in order to create use cases. We're going to focus on these 3, the consensus service, the token service, and the EVM-compatible smart contract service. All of these services are available through our SDKs in the following languages: Java, JavaScript, Go, and a community-authored Microsoft.NET SDK as well. Let's start with the consensus service, which is a topic-based public subscribe API, which allows you to record audible and immutable event data. Applications are able to subscribe to certain topics and receive messages that they truly need. There's also the audible tamper-proof log that is provided by tying these messages together. Currently in advertisement, there's a lot of intermediaries and fraud in the industry. And a lot of these businesses are charged a lot of money, and their target consumer doesn't even see their ads. So AdStacks is a company that's providing verification and events and engagement for ads using the Hedera consensus service without those high third-party costs. And they're allowing to bring data integrity into advertising. In addition, message processing and the storage is kept outside of the network, and this allows for the higher speeds and the scalability. There's also a choice. You can keep everything, you can keep nothing, or you can keep anything in between. The Coupon Bureau has been seeing a decline in the use of coupons due to their susceptibility to fraud and their lack of standardization. They use the Hedera consensus service to increase traceability and by tracing the life cycle of a coupon from creation to redemption. This raises their transparency and it raises their trust. The high speed allows for consistent view of data and real-time authentication of coupons, which can remove the redemption of fraud offers. Moving on to the token service, the tokenization service that Hedera offers makes it very easy to issue native tokens with low predictable costs, with very scalable performance and configurability. You can have scalability of up of tokens of up to 10,000 transactions per second, costing you 1 USD and H bar to create a token type. EFTPOS is a household name in Australia, and they are basically processing a lot of card payments out there. They've been trying to do a lot with Hedera, from decentralized identity to stablecoin and micropayments, but they've been dealing with the technology gap to support micropayments. So their solution has been leveraging the Hedera consensus service and the token service to be able to enable secure and affordable micropayments on the web for their users. Smart contracts. These are self-executing contracts that provide a lot of versatility. They create independence by removing the intermediaries, and they enable trustless transactions. On Hedera, you can run smart contracts that were written in Solidity and are executable in the order that they're received. They're executed in the order that they're received. There's never a need to have to pay more to be included earlier in the history. And then there's a choice to provide admin keys, which will allow owners to make alterations to the contract as well. Smart contracts are EVM compatible with a fast performance of 15 million gas per second and costing you 1 USD and H bar to deploy. In addition, with a very low carbon footprint. So why build on Hedera? Well, before we answer that, I'd like to take a moment to look at some of the challenges that most layer 1 networks have. And these challenges make it difficult for them to get adopted. Today's most networks are consuming a large amount of energy, which can prevent you from meeting your ESG goals or any personal environmental goals. There's also low processing speeds, which can prevent you from giving users a real-time experience, and your applications can just be slow and make you less competitive as well. High variable and unpredictable processing costs can make it difficult to know what your profit will be and whether you're going to be able to offer this service in a couple of months or a year from now. So that's also a major challenge, on top of security vulnerabilities based on how it's been architected and a lack of decentralization and transparency concerns as well. Hedera services guarantee that you will build applications with high throughput, fair ordering, and low latency consensus with a very low carbon footprint. So how can you start developing on Hedera? Well, the first step is going to portal.hedera.com/register and getting set up with a testnet account. These accounts get you 10,000 test HBAR every 24 hours, which is more than enough to get started and building and testing and just working with the network. For the next portion of this, I'd like to jump into an interactive workshop where I get to walk through and with you guys and code how to create a fungible token type with a supply of 0. So then we can mint the tokens and then import that account into a wallet, in this case, Hashpack. If you don't have a Hashpack wallet, that's fine. I'm going to walk through importing it and we can do that together. So for right now, I'm going to give everyone a minute or two to open up that CodeSandbox link that is attached to the YouTube description and sort of get ready. I'd also like you all to sign into your portal.hedera.com because you'll need access to your account ID and your private key as well. So let me go ahead and
should we drop the links in the chat, Abby?
Yeah, I'm going to stop sharing so I can go ahead and share my browser.
I don't know why I dropped myself off screen. I had questions and I kind of felt a bit awkward to like jump back on screen when you were talking because you were doing such a good job. Can I check a couple at you now? Do you mind? Just about some of the concepts?
Yeah, go ahead.
Whilst we wait for people to get set up. I was really interested by the quadrant of like permissioned, permissionless, public and private. Is there like, and like you're going on this journey towards like completely permissionless, which is super interesting. Right? Is there like, what would be like the justification from Hedera and why they chose to go permissioned first? Like, it's interesting. Like, if you compare it to something like Ethereum that went, or Bitcoin that went completely permissionless straight out of the gate. Like, I'd be super interested to know why Hedera took that approach. Okay.
I actually personally don't know why that approach was taken originally. If Ed, you happen to know a little bit of that history, that would be great.
Absolutely. Hey, Kev, that's a great question. And that is an important consideration that a network has to do, being proof of stake, right? You only get a chance to do this right, just one chance. And being proof of stake, if one party is able to control 1/3 of the stake, you have a compromised network. And so we, wanted to avoid that at all costs. And so therefore, we started with a council of organizations that everyone can trust. Again, you don't trust any single one organization. I wouldn't trust any single one organization, but when you have 39 of them that wouldn't compromise the reputation, just to compromise the network, then it becomes a very trustworthy system, right? And so therefore, once we build the network, a strong foundation, once we build those network effects, then it's, we thought it would be best to take that phased approach to then bring in community nodes, still KYC, still we know who they are. And then once that stake is very well decentralized, once there's a very good foundation, then we can bring in those anonymous nodes to fully decentralize the operations. But again, I'll emphasize the governance. It's a very well decentralized governance system because you have very good transparency, because everybody knows who these companies are. It's not like they're anonymous developers. And the other thing is, all the decisions and meetings that they take, they make public via meeting notes, and meeting minutes. Yeah. So therefore, that's sort of the governance and operations decentralization conversations that we had, and sort of the approach that Hedera took.
Yeah, that makes complete sense. Like, I think about it from like the way like DAOs decentralize, and they tend not to go like super decentralized super quick. But I was just thinking about it from like the technical blockchain angle, right, and not considering that kind of governance of the network. So that makes complete sense. And there was a question in the chat earlier about, and you did answer this, Ed, already, about does Hedera support Solidity for writing smart contracts? And Abby, it looked like you showed that there were multiple different SDKs written in different languages that folks can use to write to the network, like using the environment that they're comfortable with, right?
Yes, you can. You can run smart contracts that are written in Solidity in Hedera.
Okay, sweet. And then I think the other ones you said, was it Java and Go?
There's one in Java, JavaScript, Go, and there's a community authored.NET one as well.
Yeah, nice. And we also have like a beta version of Swift. So that one, will probably be out of beta pretty soon, hopefully, for those who are interested in targeting iOS devices. Yeah,
I was going to say, do you see that being people communicating directly with the blockchain from mobile devices and like mobile apps? Because if I think about Ethereum now, you'd probably hit an RPC, right? You're probably not going to run Solidity on your phone. So are you expecting folks to like build applications for the Hashgraph and the block, your DLT, like directly from Swift in iOS devices?
Absolutely, yeah. We basically made that decision to support this SDK based on demand, from developers that want to build mobile native applications.
Nice. Yeah, that's super interesting. I don't think I've seen any other blockchain, well, not blockchain, but any other DLT do that. That's wild. I'm super interested to see how that goes. Cool. We have a question from the crowd from Amplitude. Can we host, I assume they mean, can we host our own node in the future? And if so, when would this happen? And I think, Abby, you mentioned you were talking about this path to decentralization in your...
Yeah, this would be phase 2, which would be community nodes. Currently, there isn't a set time or date, but that is something to look forward to in the future.
Nice. Have you got, if I'm thinking about running a node in Ethereum, there's a huge push at the moment to create like light nodes so people can more easily run nodes. It's the effort that one needs to go to create a node for Hashgraph. Is it like comparable to Ethereum, or is it like a lighter client that you expect more people to be able to run on their own devices?
So I'm happy to jump in, Abby.
Yeah.
I think there's still a big question mark around that. What I will say that I've heard from our CTO, Dr. Lehman Baird, is that the type of computing power that you need to run that Hashgraph algorithm is very much lower than a blockchain, just because of how efficient the algorithm is. With that being said, I don't think we have even scoped out, the requirements for an actual node. So that's still very much up in the air, but I foresee that it will be similar or lower requirements, compared to something like Ethereum, in my opinion.
Yeah, cool. Because it's interesting. Like, I'd love to do it, but the size of Ethereum nodes terrify me, and I can't afford to replace my laptop.
And an interesting aspect as well is sort of the slashing and bonding that may happen in other networks. That doesn't happen with Hedera because, as Abby alluded, we have a very high security algorithm. So those incentives for good behavior with Hedera, they're baked in the technology. We don't have to bake them in the behavioral economics, basically. So what I'm trying to say is with Hedera, there's no slashing and bonding. So even if you're running your own node, you're not risking your own funds or everybody else's funds, by, if your node kind of glitches out or something like that, which I also find very interesting.
Yeah. I'm keen to dig more into that because it's like the whole concept of like the hash graph that you were explaining, Abby, and this like different approach to maintaining the network is like a juxtaposition in my brain of trying to like figure out how like where the similarities and the differences are. It's like they're achieving the same things, but the kind of like the approach to tackling that problem is quite different, which is cool.
Yes, it's a genius approach.
Yeah, proper innovation. I like it rather than just another EVM blockchain. Cool. So Abby, are you good to go? Should we?
Yeah, I'm ready to go. Ready?
Workshop. Ed, do you want to stay up here or?
I'll probably give Abby some more real estate on the screen, so I'll be in the backstage if you need me.
Thank you, Ed.
Thanks, man.
All right, go ahead and share my screen.
And thanks for the question, Amplitude.
Yes, thank you. Okay, so hopefully everyone has the CODESANDBOX link open. If not, feel free to follow along. I'm going to start on the environment file, which is a .env file. This is where everyone should be. Here you'll see that there are two keys. There's the operator account ID and the operator private key, and they're missing their values. We're going to set those values using some of the information from your portal on portal.hedera.com. The operator account ID has a 0.0, which means this is where we're going to place our account ID. I just added that in so that it was clear what was going there. So if everyone could copy their account ID and just go ahead and paste it as the value to operator account ID, that would be great. After that, we are going to copy over our private key. And something I'd like to say is that you should never share your private key. It's the easiest way to get and to lose access to your wallet, your account, and that's not something anybody wants to do. The private key that I'm going to go ahead and share, even though it is for a testnet account, I don't use it for testing. It is mainly for workshops. So even if you are working within testnet, it's always important to be safe. If you're developing, something I like to do is create a .gitignore and immediately add that environment file in there to be ignored, just so you don't accidentally push it up to your repo, which I've definitely done. Again, even though this is a test net, it's always great to be safe. So when you're doing the real thing, you already have those practices ingrained in.
Abby, could we do like a zoom or two on the screen just to get the text size up?
How's that?
Maybe one more. This is going to destroy your reader. Yeah, there we go. That looks good. Nice.
Okay, we're good?
Mm-hmm.
All right, so I'm going to go ahead and save that file. So here, everyone should have their operator account ID and their private key. And we can hop on over to the index.js file. That's going to be over on your left where all of the files are. So let's go ahead and click there. I'm going to have the fungible token example on line 20 collapsed, just so that it gives us a little bit more focus on what I want to start talking about first. Before I just start jumping in, I'll give a brief overview of what we're going to do. We are going to use the Hedera's token service to create a fungible token with a supply of 0. We will then mint tokens and then import that account that we create, which is a treasury account, into Hashpack, just in case if there's anybody joining us right now. Okay, so for line 1, all we're doing here is we're basically importing the client, private key, and account ID. This is all done because in order to interact with a Hedera network, we need to create a client. In order to create a client, we need to provide it with an account ID, and its corresponding private key. So jumping down to line 8, you can see that we use the account IDs from string method, and we pass it in the operator account ID, which then gets pulled out and creates an account ID. This is all done using one of the dependencies that have been pre-installed for you. Down here at the left, you see that there's .env that goes ahead and helps us do that. We also have the Hashgraph SDK. Since this is a Node project, we are using the JavaScript SDK. Going back to line 9 now, we do a similar thing with the private keys from string method. We are taking this private key, which is in the form of a string, and we are making it into a type private key. If you hover over it, you'll see that it's a private key. On line 12 is where we actually use the client class, and we target the test network. So we're creating a client for testnet, and we're setting the operator to be the operator account ID, which is our testnet account, and its corresponding private key. And what gets returned is a client. Once we have this client, we're ready to submit transactions to the network and start working with it. Line 18 is a supply key. This, if you look at the line, is simply a private key that gets generated. It's an ED25519, and we call it supply key because it's going to be the one in charge of authorizing the mints. What this means is that when you are changing the supply of the tokens, you need to make sure that you're secure and the one who is changing that supply is authorized to do that. The way you're going to do that is using the supply key. So although it's not important just yet, it's something that we foresee using since we will be minting tokens. So we go ahead and create it on line 18.
Abby, can I ask you a question?
Yeah.
In terms of like people thinking about this, like I always hear from folks who move from like Ethereum to Solana, for example, and you have like the account model versus the Ethereum model. Like, can you reason about the way that Hedera and the Hashgraph works in the same way that you could reason about how the EVM works in terms of like you have wallets and contracts and how that system works? Is it quite comparable on that level, even if the like implementation's a bit different?
If I'm understanding your question correctly, just basically what would be the differences between creating an account on Ethereum versus on Hedera?
It's a much better summary. Yeah.
Okay, so to my understanding, when you're creating an account, the key that is being used for that account is slightly different on Hedera, like natively by default, but it's not very different from my understanding. You can correct me if I'm wrong, Ed. You could just create your account. You'll then be able to use that to interact with the network. That's my understanding.
Okay, so the model seems quite similar. And did I hear when you said ED25519? Is that a standard that's also in Ethereum?
No, I believe they use ECDSA keys to generate their accounts, which is something that Hedera is also supporting. But by default, when you create an account on Hedera, your keys will be an ED25519 key.
Okay, yeah, cool. That makes sense. I was thinking like a different kind of standard on Ethereum versus keys. My bad. But yeah, that makes complete sense. Thank you.
Oh yeah, no problem. And you do have the option of creating an account with ECDSA with Hedera, which will make you a lot more compatible. Let's say if you wanted to import it into MetaMask as well. So that's also exciting. Okay, so continuing on with the fungible token example, this is an asynchronous function that's going to take in the supply key. And we could go ahead and open that up. And on line 21, you could see that it's just a console log that's saying that step 1 is to create a treasury account. The reason why I make that step 1 in order to create a fungible token is because this account is going to be the holder of the tokens. And since it's the holder of the tokens, we're calling it the treasury account. I've already created a helper function called create account, and that's what you see on line 24. It returns a promise, so we make sure that we await that. And it also, we pull out the treasury account ID and the treasury account private key, which will be important later on when we want to import this account. Create account takes in that client since we're using it to create these transactions and submit them to the Hedera network. And then this number of 50, what it represents is how much HBAR you're going to create this account with. This 50 HBAR is going to be coming from your testnet account. So it's important that your testnet account has enough HBAR in order to be able to fund this, plus the create account transaction fee. Once we do that, we print out that treasury account ID and the treasury account private key. Let me know if I'm going too fast. Sometimes that happens. It's code, it gets exciting, and I just want to like go through it. So feel free to stop me if I'm going too fast.
One question is: the treasury account ID, like, is that a naming convention that like you've chosen, or is it like a standard thing that is like it's enforced, or is it a pattern that you see in Hedera, or is it just your personal preference?
It's a pattern that I've seen. To call it just treasury account ID, you could definitely do a different name for that variable. Mm-hmm. So that's just something that I've seen.
Nice. Of course, it's like a pattern to try and highlight what it is, like a good naming convention, but it's not enforced by the chain.
Yes, definitely.
That makes sense.
Step 2, create a token type. This is where we're actually going to be able to code. It won't just be me talking about code. There is a helper function called create token. It's separated out into its own JavaScript file. Before we jump over to it, I'm going to just talk about the arguments. It's going to expect a client, the treasury account ID, because it is going to be the treasury account of this token that we create, the supply key, and the treasury account's private key. So over on the left, you can go over to createtoken.js, and you'll see a lot of stuff, but most importantly, you'll see that there's some errors because this file isn't fully complete. And that's going to be our job, is to basically satisfy it and make sure that there aren't any errors. Step 1 in creating a token is building the transaction. This transaction is going to be built with the token type fungible. And you can start doing this by, I'll type with you guys, const, and then create token transaction. You're going to instantiate a token create transaction. You can see that it has already been imported for you up at the top on line 1. And once you have that, you're actually going to set a couple of important things. Now, I'd like to say that this is only going to set to create a very basic fungible token, just to get the point across, get everybody sort of on the same level on interacting with the Hedera token service and basically working with it. So there is more that you could do, but for here, I'm going to keep it very simple. So we're going to set the token name, which is a publicly displayable name. I'm going to name it Hedera fungible token, but you can be creative here and you can name it what you'd like. After you've set the token name, you will set the token symbol. And I will say Hedera fungible token, so HFT for mine. Once you've set your token name and your token symbol, let's set the token type. So you'll see that there's a dot set token type, and then you have to type in token type dot, and you might see that there's a non-fungible unique and a fungible common. We will be choosing fungible common since this is a fungible token. Once we've set that token type, let's set the treasury account ID, basically saying that this treasury account ID that we've passed in is going to be the treasury account of this token. And then we'll set the initial supply to 0. We could have set this initial supply to a non-zero number, and basically when this transaction would be successfully executed, that treasury account would have that amount of tokens. But for workshop purposes, we're setting it to 0 so we can go through and mint the token. But I want to let you know that there's an option to set a number other than 0 there. And then we set the supply key, and this is where the supply key shines. What you're saying is if anybody comes and tries to change the supply of this token, they better have that same supply key that we're setting here in order to authorize that. After we set the supply key, we set the max transaction fee, which is how much HBAR you're willing to, or the max HBAR you're willing to pay in order for the transaction to go through. And once that's done, we will use .freeze with, the client. This is saying that you are expecting no further modifications. You're freezing this transaction from any further modifications. And that is, in its a simple sense, building a transaction for a token type.
It's so much easier to follow along for that than Solidity. Written in JavaScript is good. So it's like the concepts seem broadly similar. So I think it translates over quite well. Can you also set like a max supply on tokens like you can on Ethereum?
You can set a max supply. You can set fees as well. You can set keys. And there's a couple of other things on there as well. Yes.
Okay. And this is just out of curiosity, that the libraries that you're using, are they maintained by the Hedera Foundation? Is it
by Swirlds Labs? There's an engineering team at Swirlds Labs.
Okay, cool. And then so you can offset the security concerns and maintenance risks concerns of those libraries because Swirlds Labs look after them.
Yeah, and this brings up a good opportunity to be able to say that there are also HIPs which you can get involved with if you wanted to make any core contributions to the core network services. You can collaborate with others and create these Hedera improvement proposals, which will then go to the governing council, and they will see some of the changes that may want to be made. So that's also another way to get involved.
Nice. I'm curious if that's how the Swift SDK came about, and if you had a Rust dev here who might want to create a Rust SDK, they might be able to go that route as well. That's cool.
Yeah, they definitely could.
Awesome.
All right, so once we've created this transaction, we must sign it. So I like to name my variables. Usually they're very long, but I like to be very explicit. So I'm going to call it create token transaction signed.
Nice.
And what we're signing is the create token transaction that we created. So it returns a promise, the .sign. So always throw in that await. It's a small little thing to forget, but it will throw you off. So we'll say await, create token transaction .sign. And we will sign this with the treasury account private key, basically checking off that yes, this there's a relationship between them and this token type.
Nice.
Once we have that, what's left is to submit the transaction. When you submit a transaction to the Hedera network, what you will get back is a transaction response. So naturally that leads me to naming this variable transaction response. We await that. So create token transaction signed. We are executing the signed transaction, so we call execute on that transaction. And we could go ahead and execute this with the client. And you could even see if you hover over it that this is a transaction response. Once you've submitted the transaction to Hedera Network, I'd like to pull out the transaction status. So was this token type creation, was it a success or was it a fail? And whether we have a token ID, I'd like to have that token ID printed out. It is also returned in this function. We do that by requesting a receipt of the transaction. So again, const and then transaction receipt. Get receipt returns a promise, so throw in that await. Transaction response dot get receipt. Do that with the client. And from this receipt, you can now pull out the transaction status. The status, and then make sure you do a .toString on that as well. And then we can pull out the token ID. So const token ID, transaction receipt .token ID. Gotta make sure everything looks right. So we have step 1, which was building the transaction, and then signing the transaction with the treasury account private key, submitting it to the Hedera client, to the Hedera network with the client, getting that transaction response. From that transaction response, getting a receipt, and from that receipt, we can pull out the status and the token ID. And I think that satisfies everything in here. We return the token ID and go ahead and save that file. So that was creating a token type using the Hedera token service. But we still have a little bit more to do. So let's head on over to index.js. We just handled step 2. Step 3 is minting that token. Similar, I'm going to go over what mint token is expecting. It's expecting a client, which we give it, the token ID, which was returned when we created the token. This number, 100, is how many tokens we'd like to mint, and then the supply key so that it can authorize that token mint as well. Over on the left, you'll have a minttoken.js file that we can go ahead and click into. It will have missing code and an angry little red squiggle. Let's go ahead and start building the transaction to mint a token. You'll see that it's very, very similar to creating the token type. So const mint token transaction, or whatever you'd like to name it, instantiate a new token mint transaction that has already been written up here to be imported. And then we can set the token ID to the token ID that was passed in. So that is the token ID that we're going to be minting tokens for. And then we will set the amount to the amount that's passed in, which is 100. And we will freeze this transaction from any further modifications. And this one is very short, sweet, and to the point. We sign this.
The freeze with method looks like it's something that you need to remember to use a lot. It's like blocking a re-entry on Solidity contracts, like stopping, like being explicit as to where like this executable bit stops. Good.
We will then need to sign this transaction. So here's my really long name, mint token transaction signed. Make sure you await that. What we're signing is a transaction we just built above there. Not with the client. I've made that mistake before. We gotta sign it with the supply key. If you were to sign it with the client, it'd get very angry. I don't remember the exact error message, but I have seen it, and that's one thing that I always go back and check. I'm like, oh, did I sign this with the right key? So we need to sign that with the supply key, and then we could go ahead and execute the transaction. Wait, I think oh, there we go. I'm like, it's not lined up properly. Once we've signed it, let's go ahead and execute it. Remember, we get a transaction response. So const transaction response equals await mint token transaction signed is what we're executing with the client. And then we will request the receipt so we can actually get the status of that transaction to see if the token mint was a success. So const transaction receipt. We await that because get receipt returns a promise. Transaction response dot get receipt. Client. And then from that receipt, let's pull out the mint token status. Mint token. Oh, that's not what I called it. Transaction receipt dot status, not schedule ID. And then dot toString. And that satisfies that file. We'll do just a quick overview in case I went too fast, which I probably did. Sorry about that. We built the token mint transaction, signed the transaction with the supply key to authorize it, execute it, grab that transaction response, get the receipt from it, and from the receipt, grab the status, and just basically console log it so that we could see it. And that was minting a token. Let's go back to index.js. And the last thing to do is to call that fungible token example, feed it the supply key that it wants, and have a working project. So in order to run this, we need to create a terminal. Since I've blown up my browser, I don't know where it is anymore. Give me a moment to see where my terminal went. Oh, there it is. Oh, I know it isn't. Okay, as long as you've saved, you can refresh. I'm hoping it might be this one.
What do you want? You want CodeSandbox?
Yeah, I'm on CodeSandbox.
Is it this console at the bottom there? No.
There's a console, but I need my terminal.
Ah.
Oh, there it is. Okay, I refreshed and it came back. As long as you've saved, you could refresh. And there is a plus button over here on the right from the terminal. The one that you're given is read only, so you won't be able to type in there. You need to create that new one. Hopefully it will give me a blinking terminal. If not, I have a backup plan because I was prepared for technology not working. Oh no.
Okay.
Are you getting, if you're doing it with me, are you getting a working terminal? Is it just me?
I had it up, but I wasn't doing it. I don't know if anyone in the chat.
Yeah, if anybody in the chat can leave a comment and say whether their terminal is up and running or not, that would be great.
Is there like a CodeSandbox status page?
No, just CodeSandbox likes to do this. It's been doing it lately. I do have a link that I can share though. Are you able to post a link on YouTube so everybody can click on it?
Yeah.
Okay, great.
On the right of your screen, there should be like a private chat that you can drop me the link in, and then I can. Here you go. And then I can share it.
Yeah, so here's a Gitpod link which has everything already filled out, and I'd like everyone to experience actually running the code. So if it's not working on CodeSandbox for you, you can go ahead and switch to that Gitpod, which will have everything already filled out. The only thing that's going to be different is going to be the token name and the so that display name and the symbol. But other than that, the code is exactly the same. So I'm going to go ahead and switch my browser to that so that we're not just waiting for CodeSandbox. So let me stop and let me share that one instead.
I'm loading it up too. I want to see it run.
Yes, that's the exciting part. All this hard work for nothing. Okay, cool. Gitpod looks like this. The only thing you will have to do is you will have to add a .env file. So I'll go ahead and wait to see if anybody has any issues opening the Gitpod. Are you seeing it, Kemp?
I've got it. It's come up fine for me.
Okay, cool. I'm going to quickly, up on the upper left, there's a new file button. Click on that and add your .env. Just if you still,
you want to click Zoom a few times, mate?
Oh yes, definitely. How's that?
Maybe one more. Yeah, I think that's probably okay. I'm sure people will let us know if not.
Okay, cool. What you have to add for this Gitpod is this .env file because it's not added on there. If you still have your CodeSandbox open, you could just go ahead and copy and paste the same key value pairs. That would be great. So operator account ID is your testnet account ID. Your operator private key is that corresponding private key. Once you've done that, we can go ahead and get ready to run the code. I'll give everyone a minute.
The terminology like operator account and operator, is that like a
that's just a personal preference. Yeah. It could be whatever you'd like. You just have to make sure on your index you're matching it so that you could pull from it.
It's so nice to see contracts being written in JavaScript. Like the ability to onboard folks into an ecosystem, if you can do it in JavaScript, must be like so different from Solidity. It's good.
It's JavaScript's just so widely used. Anybody who is familiar with it or even not very familiar with it could just hop on, get started very quickly, start creating Hedera native tokens, and just get started. All right, I'm going to go ahead and run this. The way you do it's very simple. It's just going to be node index.js. Step 1, you'll see it's creating the treasury account. Step 2 is the token type. And then step 3 is mint tokens. So the token mint was a success. Everything worked great. It was the first time. It usually takes me like a second time because I'll forget like a line or I'll sign with the wrong key. But this was a success. I hope everyone else is seeing this. There is one last step I'd like to go ahead and do, which is import this account into Hashpack Wallet. I know we're coming up on time. I'm just going to quickly show that happening. Let me see if I could. I think I'm only sharing. I should have shared my entire. Sorry, I should have shared my entire screen.
We could see the whole GitPod screen. I don't know if you were meaning to share another one.
Yeah, I should have shared the entire window, but I'll just share it here. It's an incognito tab. So I just go to wallet.hashpack.app. If you already have a Hashpack account, this link should be attached to the video description. From here, this is going to be me walking you through importing this account into Hashpack. I'm going to go ahead and just create a password. So you could go ahead and do that. Password, agree to the terms, next. Right here, you'll have the option to import or create a new wallet. We are going to be importing, so make sure you click on Import Existing Wallet. You will have 3 options. We are interested in using the private key because that is what our GitPod returned. And we printed out that treasury account's private key. And this is where you will only need to get that treasury account's account ID. So go ahead and do that. And I will do the same.
Do you get the same problem in Hedera, where your private keys can be the same for your test account and your mainnet account?
Not that I've heard of, no.
Okay, cool.
That's
like the classic faux pas when you're developing, when you're learning Solidity, is like committing your private keys for your test wallet and not realizing that it also.
Oh, yeah, was tough. No, not that I've heard of. So this is, as you can see here, it says that this account does not exist. Mm-hmm. This is because it's recognizing that it's a testnet account, or it's not an account on mainnet. So if you check this box right here, you'll get a pop-up making sure that you understand that you're making a testnet account and to not send any real HBAR to this account. Once you click OK, you'll see that that red error message goes away because that account does exist on testnet.
Yeah.
After that, you'll have to paste in your private key that was printed out on the GitPod. So go ahead and go back to that. Once this is good, you'll satisfy those 2 requirements to get this next button down here. Can you guys see that? Should I zoom in even more? Get this next button. Once you click that, you'll get the option to name your account. I will just give it a nickname like DevDAO Hedera Workshop. That works. You can keep the select currency display as a default and then click create wallet. Once you create this wallet, you'll be greeted with a banner that makes sure you understand you're currently using testnet. You'll see that there is 50 HBAR here, which is the initial amount that you created this treasury account with. This coin, since we used a GitPod, back then I used Popsicle coin because it was really hot where I was. It's kind of cold now, so it doesn't really relate to that, but this is the coin that we created. There's 100 of them. And when you click on it, you can see that the token symbol that you've set, which was POP in this case, is set. We have the token ID. The token type is fungible. We didn't set the token supply, but it defaults to infinite. We did set the initial supply to 0. We also didn't set decimals, but it shows that it's 0. We have the treasury account. And we also didn't work with these, but there's the option for an admin key, wipe key, freeze key, pause key, and then here's the public key of the supply key. And we don't have any trade fees, but just gives you a quick insight of a couple of other things you could do with the fungible token. That was the end of my portion of interactive coding. If there are not I don't want to open up to questions just yet. I'd like to end this by showing the resources slide. So let me...
Yeah, so I was going to ask, like, what's the quickest way for folks to kind of like ramp up? You have like that those things are starting to like become apparent in the Ethereum ecosystem of like speedrun and Nada's blogs and so on and so forth. I'm sure folks would love to like know, like, if they to jump further into Hedera, like where's the next best place to go?
Yeah, so there is these resources you could go to. There's a get started guide at hedera.com/get started, which will get you set up with your environment, get you choosing an SDK, and get you through creating a client and ready to create an account. I'd say one of the fastest ways is once you have your account, use the mirror node, which is a way to be able to pull data from an account to get an account balance. Once you get used to that, then you can start working with tokens, or there's also smart contracts. You can see some guides over at docs.hedera.com, which they walk you through how to create different types of things. If you're coming from Ethereum, there's also some great guides on using Truffle to create smart contracts with Hedera, which could be a nice introduction if you're more familiar with the Ethereum ecosystem. There are also articles and tutorial videos if you're more of a visual learner. And there's always a developer Discord where you can connect with other developers, just have natural conversations about what's going on in the space and ask questions as well. So that's all places you could go to. And that's pretty much my presentation. There's a QR code here, which will email you these slides. If you'd like to go through these slides at your own pace, you will be asked a couple of questions. This is the first workshop of this partnership. It was a very introductory workshop, but this QR code will give you the option to leave feedback, what you would like to see next, if you'd like to focus in a different direction. So it'd be really important to give some great feedback on what you would like to see so we can tailor to that. Thank you.
Nice. Yeah, if you leave it on screen and give people a chance to scan it. Should we open up to, that was great, Abby, mate. Super interesting. Like, I was trying to reason about the differences myself ahead of this, doing a little bit of reading, but it's all much, much clearer now. And I love even just the idea of being able to onboard into this in JavaScript and have like that simple way of being able to write contracts in a familiar like a language and domain is, for me, is super powerful. It's really good.
Exciting. Yeah, let's open it up to any questions. You could probably bring Ed back onto the screen. He'll also be a person to answer any questions anybody might have along with me. Hi, Ed.
Hi, Abby.
I've got one quickly that I was thinking as you were going. In what's the like tooling and like particularly around like testing and build around the SDKs like? Is it just using like the existing JavaScript testing libraries, or are there like specific Hedera toolings that people should be aware of if they're coding with the JavaScript SDK?
What's really cool about Hedera right now is that you can test with Web3.js. You can test using Truffle. And do you know of any other ones, Ed, that are coming to mind? That's kind of what's coming to mind right now.
I believe Web3.js.
Yeah.
You mentioned Ethers, I believe, but also Hardhat and Truffle are supported tools. You know, if you're coming from the Ethereum ecosystem and you want to work with things that you already know. But also to your point, Kemp, if you just want to get started with JavaScript, all you have to do is install that Hedera JavaScript SDK as a dependency, and you're set to go and do all operations, with Hedera.
And then, there is also one more. You can do unit testing and fuzz testing with Foundry with Hedera. I know Foundry uses Git submodules, but there are some configuration files you can change to get it working with Hedera to do unit testing and fuzz testing, if that's something that you're interested in as well.
Nice. And for like the JavaScript in particular, I could test just with like Jest if we were just straight JavaScript and not bringing like our EVM tooling over.
Yeah, that is correct. And one really cool thing about working with these SDKs is that you're not even, you're interacting with a distributed network without really having to write smart contracts, right? Like you alluded to, there's no solidity involved. Like, and so you're not executing things on the EVM layer, you're executing things on the native Hedera layer, which gives you all those efficiencies that Abby talked about, right? Those 10,000 TPS, that 100th of a cent cost per transaction, and that very low energy consumption. And then if you want to do more complex, more advanced or flexible things, then you have that EVM compatible or available to you with all these other tools that we've been talking about.
Yeah, it seems like Hedera are really serving like the developer ecosystem with the stuff that they're building. Like if I think about like even shifting from like normal client server architecture to the cloud and then to serverless, like although those changes are quite big, like the core tools that are being used are broadly the same, right? Like you're still testing JavaScript in the same way, you're still building it in the same way. It's just like there's some extra tools around there. And it seems like Hedera's achieving that quite nicely in terms of like, we're giving you loads of new awesome powers, but you can bring your own stack to build on it.
Absolutely. Absolutely. And you know, that's what we're basically trying to achieve here, you know, onboard people while making that learning curve as easy as possible, right? Maybe using things that they already know or things that they've already been using in the past.
Exactly. Yep. It can be very daunting to, like you said, go from servers to serverless, and you're like, oh my gosh, what is this? It could be very overwhelming. So it's very important that developers can use what they know.
Yeah,
to continue to build. Mm-hmm.
You're getting people to like reason about smart contracts whilst learning this whole new language as well. Is you're asking quite a lot. Yes. And I guess the one other big question that was on my mind is there like a specific type of application that you're seeing, or like group of types of applications that you're seeing being built most on Hedera, like what it's most being used for? If you were to like, because in like EVM, you might have like it's DeFi and NFTs, right? And I was wondering, like, is there like is it becoming clear like the kind of stuff that's being built on Hedera already?
I'll take an initial stab at that. And if you remember that, you know, the different services that Abby talked about, with the consensus service, we effectively expose that Hashgraph consensus algorithm. And so we've seen, and I think that is something that is very unique to Hedera. And we've seen that used in use cases like supply chain, because, you know, if you're, let's say you're trying to manufacture something like shoes where many parts from different suppliers go into those shoes, you know, that the consensus service gives you the ability to log all those different parts and create an auditable log, a traceable log that is also transparent and public in a very cheap manner, right? So that's, for example, one of the use cases where we're seeing it. Also, the tokenization service that Abby was, you know, teaching you how to use, we've seen that being used to tokenize elements in supply chain, but also real life assets, you know, things like art, wine, real estate, and so on. And then, of course, you know, when you get to smart contracts, you have all the cool things happening with DeFi as well.
Yes. For me, I've recently started getting more into creating art, and just being able to see the community in the NFT space on Hedera is just very great. Everyone's really community oriented. They're very happy to support. If you're coming in with a new project, you're always going to feel welcome. And it's just such an exciting community to be part of if you're coming from an NFT and art perspective.
Nice. I love it. Yeah, this all sounds really, really great, guys. So just to reiterate, we have another workshop that will be coming. I can't remember if we spoke about a date yet or a rough timeline.
Don't have a date just yet, but stay posted. We will take some of your feedback, make sure that we can tailor a great talk, and yeah, just stay tuned.
Awesome. Yeah, guys, do fill out the feedback form to let Abby and Ed know kind of what you would like to see kind of from the next workshop. And we are, and this is kind of a bit driven by Abby's feedback as well, is we're gonna for upcoming workshops be moving to using Luma as an events platform for gathering people's details and contacting them. So to make sure that you hear about that next workshop, please do go to Luma and sign up. And we'll also push out some of the updates and info from the workshop today, and a link to the video for those that missed it. And yeah, keep an eye out for the announcement that comes out. Hopefully it won't be too long. But other than that, thanks so much, Abby. Thanks so much, Ed. Really, really great session, and look forward to the next one.
Yeah, thank you for having us.
Cheers, guys.
Thank you all.
Bye.
Thanks, everyone. Bye-bye.